Hi everyone. Now we are going to study about question number 56 that is related to rolling motion. So to understand about this, the very first thing what we have to understand is what is rolling motion. So rolling motion is nothing but combined motion. What it is? Combined motion of translational and rotational. So whenever the body is moving with the both translational and rotational motion performing both together, that is called rolling motion. The best example is the wheel of a moving vehicle. So it will move forward as well as rotate at every instant. So such kind of motion we call it as rolling motion. See, if you consider this is rotational motion, look at the pen. This is translatory motion. But if you consider like this, so it is moving and rotating. That is called rolling motion or combined motion of translational plus rotational. So here rolling motion, when you consider, the very first thing is what we have to understand is what is the difference between the translational, rotational and rolling motion. See here the very first thing, translational. So consider a body like this. Now this is center of mass. This is the velocity of center of mass. Then each and every point on the body move with same velocity as that of center of mass, and the linear momentum will become mass into velocity of center of mass, and kinetic energy will become half mv square. And if you consider rotational motion about a fixed axis, now the same body you fixed about one rigid support, hinge about it, so that it can rotate with some angular velocity omega. Then see, when you consider this point at a distance r, then the angular velocity is same, but the linear velocity is r omega. But when you consider this point, the linear velocity will become capital R omega, where capital R is radius of the body. That means omega is same. Omega same for every point. But V equal to different, that is R omega. So that's why the point on the periphery will have the greater linear speed. When you look at the fan, you can understand. At the edges, the fan appears to moving very faster than the point which is closer to the center. Now if you consider a body, same body, and there is one linear velocity and there is one angular velocity, that is called now rolling motion. And in rotational motion, kinetic energy is half I omega square or L square by 2I, and angular momentum is I into omega. But in rolling motion, as it is performing both, the total kinetic energy will become translational plus rotational, and total angular momentum will become rotational plus translational, where in rotational motion, angular momentum is m into r bar cross vcm bar. So r bar is position of center of mass with respect to the reference point. So that m equal L equal to mvr sine theta. So if you combine both these equations, that will come as rolling motion. Now when you consider in the rolling motion, see, like this is the one instant. Let's take this is the point of contact. Next it will move to here. 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 So like that, the path of that point is very complicated. So the path of the particle is like a kind of helical path. So only center of mass, when you consider, center of mass will not rotate. It moves along the straight line. So center of mass performs only translational motion. Remaining all particles will move with different velocities in the different paths. Now, when you consider one such point on the particle, any one point, like here you consider from the center, any one point at a distance r, there is one r omega and there is one VCM. Or if you consider here, there is one r omega, there is one VCM. So the resultant velocity of the particle will become under root VCM square plus r omega whole square plus 2 VCM r omega into cos theta. That is the vector resultant of both velocities. R omega is due to rotational motion. VCM is due to translational motion. On the periphery, VCM is equal to R omega for pure rolling. Means when you consider the rolling bodies here, topmost point will have both VCM and R omega in similar direction. But bottommost point, when you consider, the rotation is backward. So R omega is backward, VCM is forward. And when VCM equal to R omega, that is called pure rolling. And when VCM is greater than R omega, that is called forward slipping. Just like applying brake to a moving vehicle so that it will slide forward. Then VCM is greater than R omega. And when VCM is less than R omega, that is backward slipping. Just like when vehicle is trying to go up the inclined plane, then the wheel will rotate faster, but the body will move slower. Then the tire will slip backward. That is called backward slipping. But here we study purely about pure rolling, where the point of contact has zero velocity, that is VCM equal to R omega. Now, such pure rolling. So in pure rolling, when you consider the total kinetic energy is translational plus rotational, where translational means half m VCM square plus half I omega square and VCM equal to R into omega. Now, the moment of inertia also sometimes they will give as mk square, where k is radius of gyration. Now, sometimes they will ask fraction of total energy equal to translational energy. Then you have to take the ratio. See, it is like kT by k. So in kt, if you take common 1 plus kr by kt. So kt cancel. Where kr by kt is, see, kr by kt is, kr is half I omega square. I omega square by kt is half mv square equal to half of cancel, then I by mr square it will become, where v equal to r omega if you substitute, so that it will become r square by mr square plus I. or else I equal to mk square also you get, sorry, mr square by mr square plus I, or else I equal to mk square. If you substitute, the value will become r square by r square plus k square. Similarly, fraction of total energy equal to rotational kinetic energy means k square by r square plus k square, or I by I plus mr square, anything. And we have different solid regular shapes: ring, disc, cylinder, sphere. So they will give any one of such body which is rolling on a body, rolling on a surface. So then you have to apply these equations. But whenever the kinetic energy of a rolling body comes, you have to take care of what is the total kinetic energy. Now, the most important thing for our entrance is when a body is rolling down an inclined surface. See here, when you consider a inclined surface of inclination angle theta, height h, and one body started rolling from rest, then at any instant when you consider, there is one mg and there is one normal reaction and there is one friction which try to prevent from slipping. Now, if you take the components, this will become mg sin theta and this will become mg cos theta. One way you can apply that, when it reaches, suppose at the bottom its velocity v and it is coming down with an acceleration a, then apply conservation of mechanical energy, like decrease in potential energy mgh equal to increase in kinetic energy half mv square plus half I omega square. So kinetic energy means I am taking both together. If you solve this one, v square will become 2gh by 1 plus I by mr square. Now, or else what you can do is you can use the equation of motion from just like laws of motion. One is, as the body is performing translational motion, resultant force equal to mass into acceleration. That is mg sin theta minus frictional force equal to ma, where frictional force equal to mu n, that is mu mg cos theta. No, sorry. Here friction is not sliding friction. Now that is the maximum friction actually. So now the maximum friction can develop is mu mg cos theta. Now here, how much friction is developing we can find from that, because friction is the only force producing torque about the axis of rotation, because mg is passing through that, n is passing through that, no torque, only f has some perpendicular distance, that is r radius. So that the resultant torque equal to f into r, that is resultant torque means I alpha, where alpha is a by r. So that friction value will become IA by r square. Now if you substitute in this equation, then you will get the acceleration as g sin theta by 1 plus I by mr square. So this is the acceleration. Now we got velocity equation, we got acceleration equation. Now the acceleration is constant means you can apply the equation of motions like v equal to u plus at, v square minus u square equal to 2as, and s equal to ut plus half at square to find the velocity. But already we found velocity with another condition, so that no need, but you can find time taken to reach the ground, that is time equal to v by a from this equation, because u is 0 starting from rest. Now if you take this equation, if you divide both of them, 1 by sine theta into root 2h by g into 1 plus I by m r square. So this is the time taken. So they can ask comparatively comparison based questions like when two different or three different like ring, disc, solid sphere started rolling down from same inclined surface, then their masses are same, radius same, then who will reach the bottom first? Who will reach the bottom with greater velocity? Who will roll down with greater acceleration or lesser acceleration? So they will ask that comparison based questions. So you have to take care. Sometimes also they will give that they have given some velocity at the bottom upward. So to what height it will go? That means you have to apply conservation of energy. Like the initial kinetic energy should be completely converted into potential energy. So like that, either you have to use conservation of mechanical energy, or you may have to use this equation of motions, or you may have to depend on the procedure or direct formulas, whatever we have derived. Now, here, sometimes the minimum mu for pure rolling they will ask. So that means the friction here, friction is acting upward. Mg sin theta is acting downward. Now, friction should be so here the condition is our maximum frictional value mu mg cos theta should be greater than or equal to f a by r square where a equal to g sin theta by r square. Then mu value will become greater than or equal to tan theta by mr square by I plus I. So this is the condition for coefficient of friction, so that mu minimum will become tan theta by I plus mr square by I. Sorry, not I, this is 1. So 1 plus mr square by I. So this is the condition. So they can ask sometimes question based on this minimum coefficient of friction needed for pure rolling also. Now comes when examples based on whatever we have studied. When a sphere rolls without slipping, the ratio of its kinetic energy of translational to its rotational. So translational to rotational means half mv square by half I omega square. So here sphere, so they did not mention, actually they should mention whether it is solid or hollow, but if they did not mention, we have to take it as solid sphere. So that half m v equal to r square omega square by half into I is 2 by 5 mr square omega square. So r square omega square cancel, half cancel, cancel. So the answer will become 5 by 2. Oh, sorry. Total kinetic energy they are asking. So total kinetic energy means if it is, you take only translational plus rotational only. So that you add both sides 1. Then 5 by 2 plus 1. I have added both sides 1. So that it will become what? 7 by 2. No. 1 minute. They are asking the ratio of kinetic energy of translational to rotational. So that's why we want reverse. That means we want Kr by Kt. Kr by Kt is 2 by 5. Then you add both sides 1. Kr by kt plus 1 equal to 2 by plus 1 implies Kr plus kt by kt equal to 7 by 5. So that kt by k reverse if you do 5 by 7. So the fraction of total energy equal to translational. Or else we have already equation I have given the ratio of fraction of total energy equal to translational kinetic energy. You can substitute that directly. Now here when a body of mass m and radius r is allowed to roll on an inclined plane without slipping from its topmost point A, the velocity acquired by the body as it reaches the bottom of the inclined plane is given by. See, suppose a body of mass m and rolls down and slipping from it. The velocity acquired by the body as it reaches the bottom of the inclined plane is given by. See, here velocity v square equal to 2gh by, it's a direct formula based question, 1 plus I by mr square. Now they have given this value as beta. So, sorry, under root, complete under root. So that under root 2gh by 1 plus I by mr square they have given as beta, that's it. So many times they will give formula based questions also. See, the question is very big but the answer is very simple. Now the next thing is the speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding is. So again the same question based on the v equal to root 2gh by 1 plus I by mr square equal to under root 2gh by here solid sphere, so that the moment of inertia will become 2 by 5 mr square by mr square cancel. So you will get the answer root of 5gh by, sorry, 10g, 5 will go up, 5 to the 10, 10gh by 7. So root of 10gh by 7. So as I said, direct formula based questions mostly they will ask, or comparison based question they will ask. Sometimes procedure based question they will ask. Now here let's see the next question. See here, find tangential force acts at the top of a chain spherical shell of mass m and radius r. Find the acceleration of the shell if it rolls without slipping. So here the question they have given is, as you are pulling it forward, there is a chances of slipping back. So the friction will act forward here. Now, when you consider the resultant force equal to mass into acceleration, translational equation, that is F plus F equal to M into A, one equation. Another one is rotational equation, torque equal to I alpha, nothing but IA by R. Then torque is Fr plus Fr equal to IA by R. So that, oh sorry, but both torques are in opposite direction. See here, this is the position. Now R bar cross F bar is like clockwise. Here the R bar cross F bar is anti-clockwise. So the torque will become one is plus, one is minus. So F minus F equal to IA by R square. Then if you take the first equation, F plus F equal to MA, and if you add both of them, then you will get F equal to acceleration, you take common M plus I by R square, or else M if you take common 1 plus I by MR square, depends. So they are asking acceleration now. So here I am writing the final equation, F equal to F, A equal to F by M by 1 plus I by MR square. So if they are asking the angular acceleration, then alpha you can do it as A by R. So this way You can apply the procedure and you can solve the questions. They can give based on the procedure. And previously, whatever we have seen, they can ask question based on the direct formula, or they can ask comparison based questions. Now here, a uniform sphere of mass m and radius r rolls without slipping down an inclined plane. Set at an angle theta to the horizontal. Find the friction coefficient at which slipping is absent. So that means mu equal to, what is the formula? Tan theta by mr square by I. So the formula is 1 plus mr square by I. Now here, what is the object? Uniform sphere. Again, we have to consider the solid sphere only. So tan theta by 1 plus 2 by 5 mr square by I is 2 by 5 mr square. So mr square cancel. So tan theta by 1 plus 2 by 5. It will become 7 by 5 tan theta. This is the minimum coefficient of friction must be needed to avoid slipping. Next, kinetic energy of the sphere t seconds after the beginning of motion. So it started rolling down. Now they are asking kinetic energy after some time. So V equal to U plus AT after some time. So U is 0, A is G sin theta by 1 plus I by mr square times T is after time T. So that I equal to 2 by 5 mr square, if you substitute, then it will become 2 by 5, right? So that it will become 5 by 7 G tan theta times T. So the kinetic energy equal to half mv square plus half I omega square equal to half mv square plus half I equal to 2 by 5 mr square, v square equal to, omega square equal to v square by r square. So r square cancel. Then why I am converting? Because we have only v value. So that k equal to half mv square. So half mv square, if you take common, 1 plus here 2 by 5 will become. So that it will become 7 by 5. So 7 by 10 mv square. We have the v value. So if you substitute the v value, then we will get the total kinetic energy. Whatever 5 by 7 g tan theta into t is there. If they give theta and t values also, you can substitute and you can do it. So this is how you have to deal with the rolling motion. So don't try to go for the very big questions for the NEET entrance level. This kind of simple procedure based, formula based, condition based questions, you try to do it. It will be good. So similar questions I have given as assignment also. So please try to solve all the questions. Then you will get the idea of how to deal with the rolling motion. So thank you all of you. We'll continue in the next session with the next question. Thank you.